Welcome everyone to the May 13th OMR Architecture Meeting. Today we have a couple of topics. I'm not sure how long either will take to get through. The first is a topic that we've discussed in the past, and the last call we decided that we would let people have an opportunity to think about and look at the solution that Philip had proposed for the opcode tables, and decide what we want to do. I know that Philip had gone and done some experiments that Mark had requested for JIT Builder, and actually it was just in the last half hour that Mark had provided some input on that. So I don't know, Philip, do you want to address that concern if you've seen it?
Yeah,
Or do you
I
want
just
to...
commented. He was curious
Okay.
if it was debug build or not, but it wasn't.
Okay. I don't want to, I'll let him speak in the issue, but I think he'll be okay with a 0.7% increase. Myself, I mean, the feedback that I would have is I mean, it's moving us forward in a direction that I think that we want to move into. So I'm, in the absence of any better solutions, I'm fine with going ahead with that. So let's just see that get closed off, or that Mark provide his feedback on the issue. Unless anybody on the call here wants to bring up any concerns or objections or other feedback that they have on the design. Let's pause here. Okay, well, if there are concerns that anybody has, please raise them as soon as possible in that issue. Otherwise, if Mark signs off on it, then I'd say that we're free to go ahead with that.
Yep, I will comment. It is a large amount of just boilerplate code effectively until we do actually finally clean up and inline a lot of the duplication. So we do have the option of just going the if-def route, which will enable us to override evaluators. We won't have the canonicalization of names or things like that. But we could do it in a two-step process where first we let the overrides happen. We can do our downstream improvements in OpenGNI, for example. And then as a second step, we could change the names like we have it today.
Always a difficult question to ask, but once this process starts, do you have any idea how long it will take to complete? Like, if you start this and finish it in 2 weeks, you know, being in that state where we have all the boilerplate stuff might be acceptable. If it's going to prolong into months, then perhaps not.
I would say 2 weeks would probably be reasonable if we want to go the full way. If we just want to do the if-def, probably a couple days because it's very mechanical. I mean, even this change is mechanical. It's just getting the builds to actually work.
Do you think that going the if-def route would be a smoother, less chance for introducing error path? So that would be,
Yes.
yeah,
It's a
I mean,
much less riskier, and it's a knob change in terms of footprint size.
I mean, if that's the
It's all
case,
done a couple of time.
if that's the case, and we're going to end up in the same spot anyway, perhaps that is the better way
Well,
to
no,
go.
we won't end up in the same spot. The evaluators will still have different names across platforms, and I think when we delete IL or change IL names and things like that, you'll still have to do manual changes to these if-defs. But it will let us override things in OpenJ9, for example.
Okay,
I think the full renaming is a better target to shoot for. Like I think that'll be a better state of affairs at the end.
Yeah, I agree. Yeah. Okay.
Yeah,
I'll just wait a couple of days, see if Mark has any concerns, and once we're signed off, I'll just full steam ahead.
yeah, I was just trying to think if there was any advantage of doing. Yeah, I mean, I personally am in favor of the better long-term solution, right? So
Yeah. I guess it relates to your 6003 there. Because once you get to this stage, if this work is done, you can delete IL in OMR and it doesn't affect any downstream projects at all.
yeah, I mean, personally, I'm not overly concerned about that, but yeah, I see your point. So I would say let's do what we want to do, what we think is the best, what we think is the right thing to do. Let's stay on
Okay.
that path.
All right. I'll tell
All right,
Mark I'll
cool.
wait till the end of the week or if anyone else has concerns and I'll start working on this.
Okay, cool.
Thanks.
Um, okay, so let's move on to the next one. So 6003, that is a proposal to prune some vector IL opcode. So let me, we may have the sort of a chicken and egg kind of issue with, so let me provide a little bit of background here, what's motivating this.
So sorry, Daryl. Just a second, if I may.
Sure.
Am I the only one who's seeing no longer seeing what is presumably on Daryl's screen, but I'm just seeing like a
Yeah, it's
gray with
great.
the cursor over it?
I know what it's doing. Yeah, this is you're seeing it.
Oh, there we
It's
go.
when I
Yep.
switched. It's when I switch desktops to do something to look at something else, which or take notes, something like that. It 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 grays over the presentation view. So I'm a bit of a um, I guess what I well uh, you know what the agenda is. You know what I'm talking about. So I'm gonna
Okay.
just talk. um, so the background here is that um, we are looking at uh, improving the vector opcode and vector backend implementation in OMR. A lot of this is being driven by a downstream project, OpenJ9, because they are introducing a new vector API to the Java language, which is intended to map directly onto hardware instructions to get any sort of performance out of that. And there has been a bit of thought put into that API from the Java layer with the intention of, mapping it directly to hardware instructions. Um, Now, what we have in uh, the way that we would actually implement this in OMR is by recognizing various methods and then turning them into actual IL opcode codes that we have. At least that's the way that we would have done that in sort of a traditional sense. There has been various vector implementations in OMR over the years, or what you see in OMR over the years. This has been driven by a variety of different things. And if you look at the opcodes that we have, there's 109 of them at least. There is a fairly incomplete set of implementation for these various IL opcodes. Some of them were driven by certain platform requirements. Some of them were driven by features in other front ends other than OpenJ9 that required certain bits of functionality to be there. And that's why they only appear on certain architectures. Others are driven by the spimdizer, the vectorization component. So it is a fairly large set of IL opcodes. The other thing about these vector opcodes is that when they were designed, the idea was that they are all going to map to 128-bit vector length. And of course, these days, vector lengths are 128, 512, 256. There's proposals in the works for future architectures as well that go up to 2048 bits as well. So, you know, it's grown past what we are able to handle with the way that we represent vectors in OMR. So, so clearly some rethinking needs to happen here, and Gita is sort of on the forefront of thinking about how to re-represent the vector operations in IL. So we had a discussion on this at the OMR, well, one of the first OMR architecture meetings about 3 years ago. If you go back and look at the history, it's one of the first ones that we have. And actually, Gita came to that meeting then and put forth a proposal for adding vector lengths, different vector lengths to the IL opcodes. I suspect that well, one of the outcomes of that was we came up with a proposal or a set of ideas. We were going to go away and write up a proposal and then come back to the group with a with that proposal to get approved. We're kind of at that state right now where it's likely someone like Gita is going to come back with a new proposal for vector IL opcodes. But in thinking about how that should be designed, there's an awful lot of what I would consider to be noise in the IL opcodes for vector right now, in that there's sort of a core set of opcodes that we actually use, and then a whole bunch that we don't use and haven't used in any known project for many, many years. So as a first step in just sort of simplifying what we're dealing with and how we think about how we want to architect a new set of IL opcodes, started looking through the list that we have to understand what is the core set that we actually use and need, and what is a set that we don't. Actually, maybe I'll share what I'm looking at right now. I think. Sorry. For this particular issue. Do you see my browser?
Yep.
Anyone? Yep. Okay. So what I've discovered was that there's about 27 opcodes that we actually do use. And then there's a whole bunch that we don't. I'll just skip over this one for a sec, but there's a whole pile here that we don't seem to have any use for. The semantics aren't necessarily clear what they do. There's incomplete implementations for some of these as well. So when I look at the vector API that's being proposed, I was trying to think if any of these map directly to any of the operations that they have, and in many cases it isn't. I think the answer is no. There isn't sort of a use for these in that vector API. So the fact that, so with that notion, I think that many of these should be considered for removal. And again, like some of the other IL opcodes that we had removed in recent memory here, the advantage of removing them is that if somebody does come up with a use case for these in the future, when they do come back with a use case, they should come with documentation, they should come with trill tests to exercise them, and all those good sorts of things. So if we ever do need an implementation of these, obviously the code is still there in Git, so we're not losing anything here. But it's really just an attempt to get that 109 opcodes down to a much more manageable set that we can reason about. So what I was hoping was that people could review this list that I have here to see whether or not there's anything that, well, first of all, if you agree with this approach, and if there's anything in here that you think that we need to pardon. I have another set here that is also not used at the moment, but if we're going to look at families of vector, if we're looking at families that include different element types, I think these bunch down here will actually fall into some of the comparison ones up here. So like right now we have these sort of generic vector compare, equal, not equal, that kind of thing. But if we start adding ones for integers, bytes, doubles, floats, that kind of thing, these ones would just sort of naturally get represented in that. So it may be worth saving these. I also have the max and the min opcodes on here. These are more for symmetry with non-vector opcodes as well. I'm not sure if we should keep them, but I have them in this list right now for now. And the list that we do have that I think that we should keep, it consists of basically the arithmetic operations. It's got data movement opcodes and comparison opcodes. And of course the register ones. There are vector specific ones like get element and set element and splat, that kind of thing. Those are here mainly because not because they are they're here because we are using them in some capacity in either the spindizer or escape analysis is even using these, the simplifiers introducing these. So rather than think through all those cases and whether or not they're actually needed, I just kept them on this list for now. So this is why that this list may grow or contract, but it's sort of the starter set of what we have here. So I'm not thinking we have to make a decision today on this, but I just wanted to introduce this topic and get people to think about deleting a good chunk of these opcodes and their evaluators so that we can get what we have down to a more manageable set that we can reason about. And then of course, in the coming weeks, I think you will see a design proposal for a family of new IL opcodes for vector that will replace what we currently have here, and hopefully being a more sensible and documented and tested set of IL opcodes. So I'll pause there for a moment in case anybody has any thoughts or comments or questions.
So I can imagine what v compare EQ and NE might be without a particular element size, but I don't know about the ordering comparisons. I think usually the typical comparison that you're going to apply to vectors is going to be element wise with a sort of vector of results, right?
Mm-hmm.
EQ NE you can easily imagine. Okay, well we're going to check if the entire thing is equal. But what does less than mean? Is it lexicographic? Is that a common operation that CPUs have? I'm not aware of it.
So you're referring to like these four here.
Yeah.
So without an element type. So unlike what these have, where they're specifically for integers or doubles. Right. Okay. You're maybe right there. I have to see how we're actually implementing those in the backends that do, to see what operation they're mapping to. You're right. Unless the data type is somehow, the element type is somehow implicit in this.
Right.
Which would be unfortunate.
I believe the element type is based on the children in some way, that I forget the exact details. Like this even applies to like the v-add because like the 128 bits can be divided up into a different number of lanes. Like say you could have like 4 ints or like 2 longs or something like that. So we need to know that before doing the vector add.
So in this particular case, you think it discovers based on the data types of its children what operation
I'm
to do?
not sure for the comparisons, but I'm pretty sure it does that for like the v-add. Like if you scroll up a bit.
Yeah.
Yeah, I
Yeah,
have
these
a
are the
vague
types.
memory of that as well now that you mention it. So it would make sense for these comparisons to do the same thing as long as they do produce the vector of results as opposed to like a Boolean.
Yeah, I think the proposal that, well, when we had discussed this 3 years ago, I think the proposal, the conclusion from that was to go away from some of these typeless opcodes and actually introduce not just the 128, 512, and 256-bit versions, but also have byte, short, int, long, double, and float versions of them. So make the element type explicit.
Are we gonna like exponentially explode our IL?
Yes, that's the challenge. Yeah.
I think we'll need to revisit that.
And that's part of the reason why if we get the IL opcode down to the smallest multiplier as possible, we're in a, it might give us more options. If we're starting with 109 opcodes, then obviously we're up into the 2000, like almost 2000 opcodes if we go for all the data types and all the vector lengths. So when we discussed this a few years ago, we had the same kind of, this is the same kind of discussion that we had. It was the sort of the shock over the number of opcodes that this may introduce, but we need to think about ways of potentially reducing that number. So but what this particular design is about or this particular issue is just about, let's remove what we don't need right now. And it'll hopefully help us design what we do want.
Right. On the possibly to be removed list, I think I saw calls and returns, and maybe we don't currently have a use case for those, but it seems to me like those are something where there is a clear use case that could be had. It seems like to me that a language or runtime that wants to use vector opcodes will also want to return them from functions, return vectors from functions sometimes. Maybe
that would be a custom linkage for that, right?
It might not be possible with the Java Vector API that we're looking at coming up, but
does the C API even support that? Would you quote a C function that returns a vector?
I think you can in C, yeah. If you use like platform vector intrinsics, they have vector types that get allocated into vector registers, and you can pass them as arguments and you can return them.
Okay, that must be an x86 thing.
Anyway, it might make sense to remove them anyway, and re-add them if and when we want to actually support that. It just stood out to me as something that seems like a runtime would want to commonly support if it supports vectors, vector operations.
I think it would be an easy thing to add in the future if there actually was a use case for them, because obviously there would be an asymmetry with vectors and the scalar types. I guess the one thing about that would be, do we have different versions for 100, like returning 128-bit, 100 returning, 256, that kind of thing? I don't know. Those are things that we would have to think about, and unfortunately, we're thinking of I guess we're trying to keep, by introducing them now, we're providing a solution to something that we don't really have a need for at the moment.
Yep, that's fair.
I guess I could go back and try to find out when they were introduced and why they were introduced. I mean, obviously somebody had a need for that. There may be something that I can find that might motivate their existence. I mean, obviously Java doesn't need them, but I mean, who knows? There could be something to learn from that.
Right, like I think it's easy to motivate them in an abstract way, but to motivate them within OMR in terms of having support for it, I guess if we're not immediately going to have support for it, then we don't need them, right?
Yeah, linkages would have to change. I mean, I don't, maybe not necessarily in a great way, but still, you have to be able to accept and return.
Yeah.
These. So. Okay. Okay. So I know that Gita wasn't able to make this call, but I know she did want to weigh in on this before we made a decision, and she wanted to give some thought to some of this as well. So certainly not going to make a decision on this right now, but just want to invite anyone who's got opinions on this to put them up here. And I'm hopeful that we can make some progress on reducing these, if anything, just to reduce some of the technical debt that we have in the code around some of these.
Yeah, I think we need to circle back on the representing different lane widths.
Yeah, that'll
That'll kind of
be
influence
coming.
everything.
Yeah, that's why I said there's kind of a chicken and egg thing here between, between this and that. Like if we had got this down to like a set of 10 opcodes, and we were trying to explode 10 opcodes, 3 vector lengths and 6 element types, that multiplication isn't very big. But if we have a much larger set of base opcodes that we're trying to explode, then that would be that makes it more problematic. So yeah, so the other one will be coming back to this discussion group within the coming weeks. Okay, there's nothing else on that. That actually was our last topic for this week. So there's nothing else, then I think we'll adjourn now. And I've got the agenda open for the May 30th meeting. So if you have any topics you want to bring up, please add them there. I will just say that I was close to getting the annotations on the for the OMR extensible class annotations. I was close to getting that, incorporating some of the discussion points that we had in the last call that we had on that. So that might be ready in a couple of weeks for more discussion to see how that goes. All right, thanks everyone for your time today and for calling in, and we'll talk again in a couple of weeks. Thanks.